Nvidia is one of the clearest examples of how a company can start in one market and end up reshaping several others. Today, the name is closely tied to artificial intelligence, data centers, supercomputers, and some of the largest stock market valuations in history. But Nvidia did not begin as an AI company. It began as a graphics company, building chips that helped computers draw images faster, especially for video games. Over time, the same kind of chip that made games look smoother turned out to be extremely useful for the heavy mathematical work behind modern AI. That shift transformed Nvidia from a specialist in gaming hardware into a central supplier for the technology industry's biggest trend. Nvidia was founded in 1993 by Jensen Huang, Chris Malachowski, and Curtis Preem. The company is headquartered in Santa Clara, California, in the heart of Silicon Valley. At the time, personal computers were becoming more powerful, and the video game industry was pushing hardware makers to handle more complex visuals. This created demand for specialized processors that could render graphics better than a general-purpose central processing unit, or CPU. Nvidia focused on graphics processing units, better known as GPUs. In simple terms, a GPU is designed to handle many small calculations at the same time, which is exactly what computer graphics require. Every shadow, texture, reflection, and movement on a screen involves huge numbers of repeated calculations happening rapidly. The GPU became Nvidia's foundation. Its GeForce product line became strongly associated with gaming PCs, where performance matters because every frame has to be produced quickly and smoothly. For gamers, a better GPU can mean higher resolution, faster frame rates, richer lighting, and more realistic worlds. But GeForce also became important for creators, including video editors, 3D artists, animators, and designers. These users needed graphics power not just to play games, but to make visual content. This combination of gaming and creative workloads gave Nvidia a strong consumer brand and a reason to keep pushing GPU performance forward. By the first quarter of 2025, Nvidia held a dominant 92% share of the discrete desktop and laptop GPU market. The reason GPUs became so important outside gaming comes down to parallel processing. A CPU is highly flexible and excellent at complex step-by-step tasks, but a GPU is built to perform massive numbers of similar operations simultaneously. Imagine a CPU as a few very skilled workers handling complicated instructions, while a GPU is like a huge factory floor with thousands of workers doing simpler tasks in parallel. Video graphics need that kind of parallelism because millions of pixels must be calculated again and again. Eventually, scientists, engineers, and researchers realized that many non-graphics problems also worked this way. Simulations, data analysis, physics modeling, and machine learning all involve large amounts of repeated mathematical computation. Nvidia's most important strategic move was not just making faster chips. In the early to mid-2000s, the company invested more than $1 billion into CUDA, a software platform and programming interface that allowed developers to use GPUs for general computing tasks. CUDA stands for Compute Unified Device Architecture. Before platforms like CUDA, using a GPU for non-graphics work was difficult and specialized. CUDA made it far easier for programmers to write software that could send large workloads to Nvidia GPUs. This mattered because hardware alone does not create an ecosystem. Developers need tools, libraries, documentation, and a reason to build around a platform. CUDA gave Nvidia a long-term software advantage that competitors struggled to match. That software advantage became especially powerful when artificial intelligence began to scale. Modern AI models, including large language models and image generators, require enormous amounts of matrix math. Training an AI model means processing vast datasets through repeated mathematical operations, adjusting billions of parameters along the way. GPUs are well suited to this because they can perform many calculations at once. As AI research moved from academic experiments to massive commercial systems, companies needed huge numbers of chips that could train and run these models efficiently. Nvidia was already prepared with high-performance GPUs, a mature software ecosystem, and years of experience serving compute-heavy industries. By 2025, Nvidia controlled more than 80% of the GPU market for training and deploying AI models. Nvidia's role in supercomputing also shows how far the company moved beyond gaming. Supercomputers are built to solve problems that are too large for normal machines, such as climate modeling, molecular research, nuclear simulations, astrophysics, and complex engineering. These systems often depend on accelerators, including GPUs, to achieve extreme performance. According to the article, Nvidia provided chips for more than 75% of the world's top 500 supercomputers as of 2025. That statistic matters because the top 500 list represents the most powerful known supercomputing systems in the world. Nvidia's chips are not just inside gaming desktops, they are inside machines used for some of the most advanced scientific and technical work on the planet. The company's product range also expanded across professional visualization, edge computing, industrial applications, mobile processors, automotive systems, and gaming services. Nvidia developed professional GPUs for researchers, engineers, and enterprises that need reliability and high performance. It built the Tegra line of mobile processors for devices such as smartphones, tablets, and automotive infotainment systems. It also launched consumer hardware such as the Shield Portable, Shield Tablet, and Shield TV, along with GeForce Now, a cloud gaming service that streams games from remote servers. These areas are not all equally central to Nvidia's valuation, but they show the company's broader strategy: use expertise in graphics and accelerated computing to enter markets where visual processing, speed, and efficiency matter. The AI data center boom changed Nvidia's financial profile dramatically. Data centers are the physical backbone of cloud computing and AI services. They are filled with servers, networking equipment, cooling systems, storage, and increasingly, specialized AI accelerators. When companies train large AI models or serve millions of AI users, they need massive computing capacity. Nvidia became one of the most important suppliers for this infrastructure. Demand for its hardware grew as technology companies, cloud providers, startups, governments, and research labs competed for AI computing power. In this environment, Nvidia was not simply selling chips, it was selling access to the computational foundation of the AI era. This demand helped push Nvidia into the highest tier of global corporate value. In 2023, Nvidia became the seventh U.S. company to reach a $1 trillion valuation. Then, amid intense demand for AI data center hardware, the company went even further. In 2025, it became the first company in the world to surpass $4 trillion and $5 trillion in market capitalization, according to the article. Market capitalization is the total value investors assign to a public company, calculated by multiplying its share price by the number of shares outstanding. These milestones reflect investor belief that Nvidia sits near the center of a long-term shift in computing. Nvidia's rise also explains why it is grouped with the so-called Magnificent Seven, a label used for some of the largest and most influential technology companies in the stock market. These companies matter not only because of their products, but because their size affects major indexes, investor portfolios, and the direction of the technology economy. Nvidia's inclusion in this group shows how much the market's center of gravity has shifted toward AI infrastructure. In earlier eras, the most valuable tech companies were often defined by software platforms, search engines, operating systems, e-commerce, or social networks. Nvidia's position highlights a different reality. The physical chips powering computation can be just as strategically important. The key to understanding Nvidia is that its success came from combining hardware, software, timing, and ecosystem control. The company built powerful GPUs for graphics, then invested early in CUDA so developers could use those GPUs for much more than games. When AI models began requiring enormous parallel computing power, Nvidia already had the chips, tools, customers, and credibility. Its dominance in gaming GPUs, Professional computing, AI training, deployment, and supercomputing did not happen by accident. It came from years of compounding advantages. Nvidia's story is not just about one company becoming extremely valuable. It is about how the architecture of computing changed, and how a graphics chip became one of the most important engines of the AI age. If you found this helpful, please like this video and subscribe for more explainers.